Hey guys, today we are talking about transformations. This is Unit 9. Remember that we are doing transformations a little bit out of the textbook order if you are looking at that. Okay, so when we talk about transformations, we have 4 different transformations that we talk about. Okay, we have reflection, which means we're pretty much taking a mirror image. We have translation, which is where we're going to slide an image left, right, up, or down. Okay, rotation means we're going to turn that image, so the orientation of it is going to change. And then dilation is when we're going to change the size. Okay, so we're either getting bigger or we're getting smaller. So as we go through these, we're going to look at the rules that are attached to the points, and we're going to look at some examples, and then we'll call it a day. Okay, so the first one that we're looking at is a reflection. Okay, so a reflection is a transformation over a line called the line of reflection. Okay, sometimes we're going to hear that referred to just as the line of symmetry, so make sure that you keep that in mind. Okay, each point of the pre-image, the starting image, and the reflected image are the same distance from the line of reflection. Okay, I am going to go ahead and have you add in the word symmetry right here. Whoops, let's try that again. Okay, that way you just know if they call it the line of symmetry, they're talking about the same thing. Okay, so we are going to focus on reflecting over three different things. We're going to reflect over the x-axis, over the y-axis, and over the line y equals x that goes through the origin. Okay, when we reflect over the x-axis, okay, we start off with our original point as xy. Okay, then our new point, our reflected point, okay, the x stays the same, and we take the opposite of y, which we're going to write down as negative y. So if we look at an example of this, if we have the point negative 1, 2, and we're trying to get our new point, okay, then our x stays completely the same. So we're still going to have negative 1, but our 2 becomes opposite of 2, and the opposite of 2 is negative 2. So that would be our new point, our reflected point over the x-axis. Okay, our next one is a reflection over the y-axis. Okay, again, we're starting off with that original point, xy. And our new point, okay, when we reflect over the y-axis, is that our x is going to be the opposite. So we're going to have negative x, and our y stays the same. Okay, so again, another example. Say we have the coordinate negative 3, negative 4. Okay, then our x becomes the opposite of what it was. So the opposite of negative 3 is positive 3, and y stayed the same, so it's still going to be negative 4. Okay? So then our last one is when we are reflecting over the line y equals x. And when we reflect over the line y equals x, our coordinate, our original coordinate xy, flips places. So neither one is becoming the opposite, but they are flipping location. So the y coordinate will go first, and the x coordinate will go second. So say we had, I don't have much room here, but say we have 2, negative 1 as our coordinate. Then our new coordinate over here would be negative 1, 2, because they just flip places. Okay, so that's looking at reflection. All right, now we're going to go to our second one, which is translation. Okay, so a translation is a transformation that moves all points. Okay, it moves, if there's 4 points on the figure, you're moving all 4 points. If there's 3 points, you're moving all 3 points. Okay, of the original figure in the same direction and the same distance. Okay, so we're moving it in the same direction and in the same distance every time. So with our example down here, we are translating using a vector, and we're going to refer to our vector as a comma b. Okay, our A coordinate is going to go with X because it comes first, and our B coordinate is going to go with Y because it goes second. So our X, when we start out, we have our first point, XY. Okay, and so we add A to X plus A, and then to Y we're adding B, so Y plus B. Okay, so our X is always our horizontal movement. I'm going to change colors here for a second. Okay, so our horizontal movement is our X, and our vertical movement is our Y. Okay, so let's look at an example. All right, we've got our vector is going to be 3, -2. So that's our A and our B. And our original point is going to be point P. Okay, and we're going to say that that original point is 6, 5. So what we have to do to get our new point P, we're going to call it P prime, is we have to add in that vector, or we could be subtracting. Okay, so we're trying to get this new coordinate, our new X and our new Y. So we have our original point 6 plus our A from our vector, which is 3. So 6 plus 3 gives us 9. So our new coordinate for X is 9. And then we have 5, and we have this -2. So technically we could write this as 5 plus -2, but most of us would rather just write 5 minus 2. And 5 minus 2 gives us 3. So we move to the point 9, 3. Okay, now it might also help just as a little extra here. So our X, okay, if the X is positive, then it's moving us to the right. Okay, if our X is negative, it moves us to the left. Okay, and then our Y's, if our Y is positive, it moves us up. And if our Y is negative, it moves us down. So just a little extra information there to throw in. Okay, so let's look at an example of each of these. So on the next slide, I've got our examples. So we're going to start with reflections. Okay, so with our reflections, I already plotted our original points. So we have -2, -1. Let me shift my graph so they're actually in the right place. Okay, so -2, -1 is point D. So here's D, our original D. -1, 3 is our point E. And F is at 3, -1, which is right here. They tell us that we are reflecting in the x-axis. So when we reflect over the x-axis, remember we have our original point xy, and our new point, our x is going to stay the same, and our y is going to become the opposite. So we're going to have D prime, E prime, and F prime, because we have 3 points that we are reflecting over the x-axis. Now remember, the x is always associated with the horizontal. So our x-axis is our horizontal axis, so this is what we're reflecting over. Okay, so our new D point, if x stays the same, then we still have -2, and our opposite of -1 is +1. E prime, x stays the same, so it's -1, and 3 becomes the opposite, so it's -3. And F prime, x stays the same, so 3 stays the same, and the opposite of -1 is +1, so those are our new points. Now, to graph this, you can just graph these points that we have here, D prime, E prime, F prime. Okay, but you could also look at the graph. So we see that point D is 1 unit away from the line of reflection. So that means that it has to be 1 unit on the opposite side. So that would be where D prime is. Now we also see that that point is still -2, +1, like we found right here. Okay, so let's look at E. It's 3 units up, so we're going to go 3 units down. Okay, which does put us at -1, -3. That's E prime, and then F prime is at over 3 and up 1. okay, which is 1 unit from the axis, the line of reflection. So if we connect those together, let me do a better job on that one. Okay, then that is our reflected triangle. Okay, so then we're moving to to translations. Alright, so our original image, they did the picture for us. Okay, but we're going to look at the work that we have to do. So our original points they gave us right here. Okay, and they already wrote them for you right here. Okay, so they want us to graph the figure and its image along the vector 2, -1. Okay, if our vector is 2, -1, this would be A and this would be B. So that 2 we know goes with our X, and it's positive, which means we know that we are going to the right 2 units. And then B goes with the Y and it's negative, which means we are going down. So we are going down 1 unit. So here we go from XY, our original point, to our new point with this vector. So we have X plus 2 and Y minus 1. Okay, so we're looking at our new coordinate. For R, we would have -2 plus 2, which is 0. Then we have -1 minus 1, which is -2. For E prime, we have -2 plus 2, which is 0. Then we have 2 minus 1, which is 1. Then C prime, we have 3 plus 2, which is 5. And 2 minus 1 is 1. And then T prime, 3 plus 2 is 5. And -1 minus 1 is -2. Okay, you could also look at the graph, and if this was the original E point here at -2 or -2, 2, then to get to the new E, we went to the right 2 spaces and down 1, just like it told us to. Alright, so moving on to rotations. Okay, rotations is a little bit different. So a rotation is a transformation around a fixed point called the center of rotation through a specific angle and in a specific direction. Each point of the pre-image and the image are the same distance from the center. So again, we're primarily looking at 3 different rotations. Okay, we have around 90 degrees, 180 degrees, and 270 degrees. We are primarily talking counterclockwise, but you could rotate clockwise as well. So for 90 degrees, the coordinates switch places and the y becomes negative. So if our coordinate is 3, -4, then we're flipping places. So we have -4, 3, but then we take the opposite of y, which makes it 4, 3. For 180 degrees, the coordinates don't switch places, but they both become the opposite. So if our coordinate is -2, 6, the opposite of -2 is +2, and the opposite of 6 is -6. Then we have our rotation of 270 degrees. And so if we start with xy, then the coordinates flip and the x becomes negative. So we have y, -x. So if we have 2, -3, then our new point would be, the y stays the same, just puts in a different place, so -3, and the opposite of 2 is -2. So that would be our new coordinate for rotations. Okay, so if we look at an example with rotations, okay, this says the trapezoid FG, H, and I has the vertices F, G, H, and I at those points, and we want to rotate 90 degrees. So when we rotate 90 degrees, we're going from XY, and our point, our flipping places in the Y becomes negative. So our F point is 7, 7. So our F prime, we flip places and the y becomes negative, so -7, 7. Then we have G at 9, 2. So G prime, they flip places, and the original y becomes negative. So we would have -2, +9. H is at 3, 2. So again, for H prime, flip places and the y becomes negative. So we have -2, 3. And I is at 5, 7. So I prime, they flip places and the original y becomes negative and the x stays the same. So there would be your new coordinates. Okay, so make sure that you're careful, just as a side note, if we had A was at, if A was at 2, -5, okay, that our new point would be, our A prime, okay, would be a +5 because the opposite of negative is +2. Okay, so just be careful when there are negatives involved. Alright, the last one we need to talk about is dilation. Okay, so a dilation is a transformation that enlarges or reduces a figure proportionally. We'll talk more about proportionally a little bit later in the year. Okay, dilations are completed with respect to a center point and a scale factor. Okay, scale factor is what our primary focus is here. When we have scale factor, that means that we are going to primarily be multiplying. Okay, we could be dividing when it's a fraction, but that's a version of multiplying, okay? So, when we dilate, okay, we take our scale factor and we multiply it times the original point. Okay, they tell us that R represents the scale factor. So we started with our point xy, and then we went to our new point R times x, comma R times y. So if I tell you the scale factor is 7, and the original point P is 3, -1, then we want the new point P, P prime. So we take the scale factor, 7, and we multiply it times each point. So we have 7 times 3, which is 21, and then we would have 7 times -1, which is -7. So that would be our new point. Okay, so let's look at one more example of a dilation on the next page. Here we have the scale factor is 2.5, so your scale factor can be a decimal, but we're doing the same thing. We would have 2.5 times x and 2.5 times y. So you would just take each number and multiply it times 2.5 to get your new numbers. So 2 times 2.5 is 5. So A prime is 5, 5. B prime, we have 3 times 2.5, which is 7.5. And then 4 times 2.5, which is 10. C prime is 5 times 2.5, which is going to give us 12.5. And then 2 times 2.5 would be 5. Okay, I did want to point out that you need to be a little bit careful when you graph these. Okay, because on this graph we have it going up by 2. So we have 2, 2, 3, 4 is in between. Okay, and then 5, 2 is over 5 and up 2. So there's our original triangle. So then our new triangle, we have 5, 5. So in between 4 and 6, and in between 4 and 6, so in the middle of the box. Then we have 7.5, which is going to be closer to 8, and up 10. And then we're going to have 12.5, which is in between 12 and 14, but closer to 12, and then up 5. So there would be our new triangle. So that's all we've got with transformations for main ones. If you need any additional help, please come see me for the notes or more help. And always remember to use your notes on stuff like this, okay? Have a great rest of the day.